So we're going to be finding pods, vertical asymptotes, and horizontal asymptotes algebraically. The first thing we want to do is make sure that our function's in factored form. So if we look at example 1, our numerator and denominator is already factored for us. So we can start by finding the pod. The pod, or the whole, is always going to occur at the common factor, which in this case is going to be at x equals 1. Then we need to find the y value of the pod. So we're going to do the limit as x approaches 1 of this function. So if we want to find the limit as x approaches 1 of this function f of x, we can simplify our function by crossing out this common factor and substitute in 1. So we'll get the limit as x approaches 1 of f of x is going to equal 3 over 4. So that means my pod, or my whole, is going to occur at the point 1 and 3/4. Once we find the pod, now we can find the vertical asymptote. We can use the simplified function we have up here, so x plus 2 over x plus 3. The vertical asymptote will occur where this function's undefined, so I could set the denominator, x plus 3, equal to 0, and find that the vertical asymptote occurs at x equals -3. Once I have the pod and the vertical asymptote, I'm able to figure out the domain of this function. We did this earlier this year, that if I look at my original function, f of x, I know that the domain cannot include x equals 1 and x equals -3, as they make my function undefined. So that means I can write my domain as -∞ to -3, and -3 to 1, and then from 1 to infinity. Before moving on to find my range, I'm going to need to figure out my horizontal asymptote first. I do that by finding the limit as x approaches infinity of my function, or the end behavior. So if you recall, we did this last unit. It's helpful if I rewrite this as the limit as x approaches infinity of our function multiplied out, which is x squared plus x minus 2 over x squared plus 2x minus 3. As you can see here, my highest degree on the top is equal to the degree on the bottom. Both of these are x squared. And our rule here for end behavior is when we have the degree on the top equal to the degree on the bottom, my answer is going to be the coefficient. So in this case, the limit is going to equal 1. So that tells me that I have a horizontal asymptote at y equals 1. Now that I have the horizontal asymptote, I can find the range of this function. We know that the y values that are not going to be included are 3/4 and +1. That's because I have a pod at y equals 3/4 and a horizontal asymptote at y equals 1. So I can write my range as -∞ to 3/4, 3/4 to 1, and from 1 to infinity.